Hey everyone, we're going to start talking about lenses in this section. We just finished mirrors that reflected light. Lenses are going to refract light. We have two different types of lenses, converging and diverging, just like with the mirrors. Your converging lenses, they bring your light rays together. You can see that when the rays are going through the lens here, that they are coming together, getting closer together on the other side. Your converging lenses are thicker in the middle. That's how you can distinguish them from the diverging lenses. The diverging lenses, they cause your rays to diverge. You can see the rays are going through and then they are coming apart. So the diverging lenses are thinner in the middle. Let's take a look at this question here. You can use the sun's rays and a lens to start a fire. What type of lens should you use? Well, if you want to start a fire with the sun's rays, then you want all of those rays to come together. And that is what a converging lens is going to do. It's going to bring them all together. The other thing I want to talk about in this video is the focal points of lenses. When we talked about mirrors, we talked about the fact that your mirror had a focal point that was half of the center of curvature. So if you had a concave mirror here, and maybe it had a focal point here, and then when your rays were incoming parallel, then they would reflect through that focal point. The convex mirror had a focal point on the other side. When your incoming rays were parallel, then when they reflected, they appeared to reflect from that focal point. So your lenses are slightly different. They have two focal points, one on each side of the lens. And this is because the light can come in from either direction. If you have a converging lens here, this demo shows that the light is coming from the left. Those parallel rays are then going to converge at the focal point. But if the light was coming from the other side, then the rays would converge on the other side because there's a focal point on the other side as well. This demo over here on the right shows a diverging lens and the rays coming apart when they go through. What determines how much bending occurs when the light goes through these lenses? Well, it's two things. It's going to be the curvature of the surface, right? The angles make a difference. And also the index of refraction. We learned that the index of refraction, the higher it is, the slower the light is and the more bending of the light in that medium. So this picture shows us the same thing again about the focal points. When your rays are parallel, then they're going to converge through the focal point on the other side. If you have a diverging lens, when the rays are parallel, they're going to diverge. But if you trace them back, then it's as though they diverged from that focal point. Let's look at one final question here to see if we understand the definition of the focal length. So let's just look at each one by one and see why it is or is not a good choice. The focal length of a converging lens is a distance at which an image is formed. So that is not a good choice because the image is only formed at the focal point if the incoming rays are parallel. Otherwise, the image can be formed anywhere else. What about B? The distance at which an object must be placed to form an image. That's not true either because the object can be anywhere. It doesn't have to be at the focal point. C. The distance at which parallel light rays are focused. That is the correct one. Your parallel rays, they come in parallel to that lens, then they're going to be focused at that focal point, and that is where your image is going to be formed. Only when the rays are parallel. So D is not a good choice either. The distance from the front surface to the back surface. So this distance here, we're actually going to ignore it because we're dealing with thin lenses, which makes that distance negligible. So that's it for thin lenses for this video. In the next video, we're going to learn about the ray diagrams and finding our images where they're going to be created.